Welcome back to my YouTube channel Statistics for Beginners. Today we'll be discussing one of the important topics in experimental design, that is Latin square design, and it is also one of the series of videos for this upcoming examination Inspector of Statistics conducted by APSC. So let's begin with the introduction of this Latin square design, and before that we'll be observing one of the questions that has come in the previous year exam conducted in 2023 of this Inspector of Statistics regarding Latin square design. So this is the question, question number 7 of B. Explain the concept of Latin square design, elaborate on the procedure of framing its layout, mentioning about the application of the principles of design of experiments, write down the model used to define an LSD, explaining the terms used. So this paper, the statistics paper of Inspector of Statistics, is a subjective paper. This question is carrying 5 marks. So from this part 2 section of this question paper, you have to attempt any 5 questions. So these are some of the subjective questions during the examination could be attempted in a point-wise manner also, because the question has been divided into certain kinds of parts. So let's begin with the introduction of this LSD or Latin square design. So sometimes in field experimentation it is found that soil heterogeneity varies in two particular directions, that is north to south and east to east, east to west, or south to north and west to east. Thus in this type of field we require to frame blocks into perpendicular direction which take care of the heterogeneity in both the direction. LSD is such a design which has got capacity to handle such known source of variations among the experimental unit. So LSD is also one of the design of experimental designs, and it is also one of the most effective design we can say, because it is controlling the variation in two direction. The fertility gradient of the soil may be effect in two directions. So LSD is the most we can say in among the experimental design, it is the most sophisticated design of field experimentation which is controlling the variation in two directions. A Latin square design is an arrangement of treatments in such a way that each treatment occurs once and only once in a row and each column. This type of allocation of treatment helps in estimating the variation among row block as well as column block. Subsequently, the total variation among the experimental units are partitioned into different sources, namely row, column, treatment, and errors. If small t is the number of treatment, which is also equal to the number of replication for each treatment, then the total number of experimental unit needed for this design is t by t. These t square units are arranged in t rows and t columns. So when we study about experimental design, we come to know that certain experiments are designed in such a way the treatments and the number of replications may vary, but for this LSD, the number of treatments should be equal to the number of replication. Therefore, it has been assumed in this slide that the number of treatment is also small t and the number of replication is also small t. So if we have 3 treatments and 3 application, then our LSD will be 3 by 3, and this 3 by 3 means 9 units will be divided into 3 rows and 3 columns. The condition for appearance of treatment once and only once in each row and each column can be achieved only if the number of application is equal to the number of treatment. So it could be considered as one of the restriction also in LSD, that here number of treatments should be equal to the number of replications. Now the layout and how the randomization principle will be followed. So as this is one of the experimental design, here also all the principle has been followed: replication, randomization, and local control. In LSD, all the 3 factors, that is treatment, rows, and columns, are at the same number of levels. It has also been mentioned that a treatment should appear once in a row and once in a column. The above condition have made the layout of the design more complicated compared to the other 2 basic design discussed earlier, that is RBD and CRD. So RBD in my videos I have not discussed till now, but CRD I have discussed. CRD doesn't follow this principle of local control. It follow the principle of replication and randomization, but RBD is a design. It would be discussed in my upcoming videos, that it follows the three principle of randomization, replication and local control. A Latin square is called a standard Latin square when the treatments are arranged in the natural order or systematically in the first row and first column. So this is the layout of 4x4 standard Latin square. As you can see, in the first row and first column, the treatments are in a alphabetical order. Similarly, this is also one of the example of our Roman 2 is an example of 4x4 LSD, and Roman 3 also is an example of 4x4 LSD. So as we know, all this design, experimental design, foundational basis are from your ANOVA models, the analysis of one-way variance model. So here also it is one of the linear ANOVA model, we can say, or we can say it is a LSD model. So we have different types of variation which is influencing the here the dependent variable, or we can say the response. So that there will be small t treatments, so there would be small t rows and small t columns. So we need a field of t by t experimental units. The appropriate statistical model for the analysis of the information from a t by t LSD can be given as follows: y suffix ijk equals to mu plus ri cj t suffix k e ijk. So here the notations are explained. What is mu is the general mean effect, we all know. Small ri is the row effect. Small c suffix j is the column effect. Small t suffix k is the treatment effect, and we have the error effect, or we can say the chance effect. So these are some of the formulas that can be used while calculating some of the problems while solving some of the problems regarding LSD. So first we have to calculate the correction factor, then our total sums of square or total variation, then row sums of square, column sums of square, treatment sums of square. This all the variations should be calculated separately, then finally the error sums of square. And after all this calculation, we will be having one ANOVA, just like our ANOVA table. We will be having ANOVA table for LSD, where our sources of variation, first column will be rows, column, and treatment and error, and our second will be our degrees of freedom, third will be our sums of square, fourth column will be our mean sums of square, and finally the F ratio, Standeker's F ratio. This is variance ratio. This is one of the important calculative measure in this ANOVA table, because it helps us to give conclusion regarding either we are accepting a null hypothesis or we are rejecting it. So we'll be getting three F calculated value from this LSD. One is for rows, one is for column, and one is for treatment. So how the decision either to reject or accept the null hypothesis of certain kind of treatments, rows and columns could be explained in this slide. The null hypotheses are rejected at a level of significance if the calculated values of F ratio corresponding to treatment or row or column be greater than the corresponding table's value at the same level of significance with same t minus 1, t minus 1 and t minus 2 degrees of freedom respectively. That means we reject H naught if the value of F calculated value is greater than F tabulated value. Otherwise one cannot reject the null hypothesis. When theta is non-significant, we conclude that there are no significant differences among the treatments, rows, columns with respect to the particular characters under consideration. All the treatments are statistically at par. So this is the rule for any kind of statistical test, that calculated value should comes up to be greater than the tabulated value. Then only we can reject a null hypothesis at a certain level of significance. Either we cannot reject the null hypothesis. When any of the three null hypotheses is rejected, then it is required to be identified that which rows, columns, treatment are significantly different among themselves and which treatment is the best treatment. So if we are considering 4 to 5 treatments and we know that they are significantly different, but we don't know that either which of the treatments are pair are significantly different, then we can apply some of the post-Havoc test we have. This is calculated as a critical difference or least square difference. This test is very much common among the post-Havoc test, which is calculated to give conclusion regarding which pair of treatment is significantly different. One of the main characteristic feature of LSD is that as the number of treatments, number of rows, number of columns are equal, the estimate of the standard error for each treatment means column mean and row mean are same and is given by this. Standard error of difference formula we have to calculate with square root of 2 error mean square divided by small t. The critical difference for rows columns treatment at alpha level of significance with error degrees of freedom is given by this formula. So this critical difference is first calculated, and this critical difference value, if comes up to be greater than our difference between two treatment means, then we will be saying that the two treatment means are significant. And if it is not greater than our difference between modulus of two treatment mean, then we will be saying that the treatment means are not significant. So just right now I have said you that has been mentioned in this slide. Difference between any pair of means of rows column and treatment be more than critical difference. Calculate whether then rows are significantly different from each other and otherwise not. So there are some of the advantages and disadvantages of LSD with respect to our CRD or RBD design. So advantages are like Latin square design is an improved design over the other two basic designs, CRD and RBD, as it takes care of the heterogeneity or the variation into particular direction. Experimental error is small for LSD as compared to RBD and CRD because of double grouping. In LSD, missing observation can be analyzed by the missing plot technique. Disadvantages are there. The LSD design is heavily disadvantageous because of the fact that number of replication is equal to the number of treatments. So this is one of the restriction that is been imposed in LSD apart from our CRD and RBD design. The layout of the design is not so simple as was is in the case of CRD or RBD. With the increase in size of the square, experimental error is likely to increase. Now, what is the conclusion from this whole lecture on LSD is that the Latin square design is a powerful tool for reducing experimental error and controlling for the two sources of variability, rows and column. It is widely used in agricultural, industrial, and clinical experiments where it is important to control for spatial or temporal effect. However, its applicability is limited when more than two factors needed to be controlled, and its assumption must be carefully checked to ensure valid result. So this is also one of the important point that any kind of statistical test, we have to see the assumptions either they are fulfilled or not. So this was a short video regarding LSD, and this is also one of the important video in this series of lecture for Inspector of Statistics, because question has come from this topic LSD. So I hope more videos will be there in the upcoming days. Thank you all.